Okay, what is 5C all about? If you want to talk about integration, so every time when you talk about 5C, you want to talk about integration, what type of function will the question give you? The question will give you what type of function? Will they give you displacement function? No, they will give you given velocity function. Why they want to give you velocity function? Why they want to give you velocity function? So that you can apply your integration. Why they want to give you velocity function? The reason is because velocity is the rate of change of displacement. So I have the conclusion: area bounded by the velocity graph represent what? Represent what? Okay, represent total distance traveled. So this is a very important fact that you have to know. So if I give you a displacement, a velocity time graph like that, A, B, then here is C. I ask you to write an expression that represent total distance travel in the first C second. How will you do it? Okay, now everyone take some time to write. They won't tell you is integration, but you know you definitely have to do integration. So now everyone take some time to write the expression. Very careful of the position of the yes. Yes. Okay. You have to be very careful with the position because this area is below the x-axis, below the t-axis. Correct? So you have to be very, very careful if the area is below the x-axis. So what you need to do is, we try not to use modulus, correct? I told you already. So my answer will be integrate. Instead of write 0 at the bottom, I put the 0 on top and a at the bottom. Vt dt. This is the red part, the first red part, plus integrate from a to b Vt dt. So this is called the expression. Then plus. Okay, instead of b to c, because you will get a negative value, you want total distance travel, so you have to put c to b. So this is what you mean by, yeah, kinematic. Under kinematic, you have to know that the area bounded by the velocity time graph represent total distance traveled. Okay, if you integrate straight away from a to 0 to c, Vt dt, this is called the displacement. After c second. Are you clear? Are you clear? So if you integrate from 0 to c, you got positive value. That means the particle is at the right of the origin after c second. If you get negative, that means it will be at the left of the origin after c second. That's all. So you have to be very, very careful. Whether I'm asking for total distance travel or whether I'm asking for displacement. Are you clear? Displacement is the position. If you integrate directly, it gives you the displacement. So get it right for both. Are you okay? Okay. So all the application there, you have to do the exercise 5C.1, 5C.2, and 5C.3. So I'm going to discuss the longest question in 5C.2 with you. Can you tell me which question is that? The longest question. Okay, 7. So I'm going to give you some time to do question 7. So every time, whenever we do this type of application question, first of all, we key the function into our graphic calculator. Yes, why you play with your handphone, young man? Your textbook. Okay, you have to let me know. If not, I thought you are playing with your handphone. Okay, so everyone go to question 7. Take out your graphic calculator on page 142. So exercise 5C.2, question 7, page 142. Okay, 10 minutes for you to try. Then I will discuss one by one with you. If you have any question, you can ask. Okay, so the first part, so you see, that is how when I read the question, I interpret, I write down the initial situation. Okay, so the starting point of these two animals is a different starting point. So that one we have to take notes of. Okay, so the first part of the question is very simple and straightforward. You use your graphic calculator, you get the velocity of the lion is 13 point. The one you can straight away from your calculator. You don't even have to show me. So approximately 13.6 meter per second. So, yeah. Then for the zebra is 1.90325. So approximately 1.90 meter per second. Right? So the lion run much faster than the zebra after 1 second. Correct? Okay, then after that, the part B, they say, show how the lion's speed decreases over time. Whereas the zebra's speed increases over time. When you say over time, that means as time passes. So what I do is, there are two ways of doing, 3 ways, I will say 3 ways of doing it. So if you can go by graph, let's go by graph, okay? Because why I want to go by graph? Because after that, there's another part that they explain why the lion will be closest to the zebra at that time. So I want to see how the velocity of the zebra with respect to the velocity of the lion. Who is running faster at what time? Correct? So I draw the graph. So part B, I sketch the graph first. So I sketch the graph. So do you see, whenever you talk about time, you must start from 0 onward. So don't waste your time at the negative part of the graph. So all go with the positive part. Okay, and this is exponential. We know that any exponential term, it will not go below 0. So for the lion, it go like that. All right? It start with 15. Yeah. So this is my V1 T. That is for the lion. You can label in your exam, during your exam. Okay, so I can explain, I say from the graph, and as time goes, velocity will approach 0 from the top, right? And the gradient of the velocity time graph is negative, right? So that shows that the velocity is always positive and is always decreasing. So therefore, the speed is always decreasing. You see how I explain? You got the graph, you have to explain this way. You say, as time passes, the velocity approaches 0 from above. Yeah. So the velocity of the lion approaches 0 from above, which means that the velocity is always positive. Yeah, and the gradient of the velocity time graph is negative. Am I right? So that shows velocity is decreasing and positive, therefore speed is decreasing. Because different sign, decreasing speed. Am I right? That is what we know. If you are discussing from the aspect of the graph. Okay. So when you talk about the zebra, the graph, it starts from 0. Am I right? Then the graph go like that. Okay, this is for the zebra. So the zebra start with the velocity of 0. As time passes, the velocity of the zebra approaches 20 from above, from below. Am I right? Yeah, and the velocity time graph for the zebra is positive. So that shows that the speed is always increasing. Right? So you have to talk about the gradient. That means I'm telling you about the acceleration as well. Acceleration is positive, velocity is positive, so speed increasing. Am I right? Okay, so that is one way through the graph. Then you have to elaborate the graph. Are you clear? Okay, if I don't want, I have another alternative. I didn't write, you write by yourself. Everyone, are you okay? Okay. So another way is you draw the velocity time graph and acceleration time graph. So what you need to do is another way of doing it. Okay, let's go for the lion first. The VT, V1T is equal to 15 e to the power negative 0.1 t. So this is always greater than 0. Okay, then you get A1T. That is negative 1.5 e to the power negative 0.1 t. Are you okay? Are you okay with this? So this is always negative. Yeah. So therefore, conclude speed decreasing. Can or not? Can also do like that, because you see, if I draw a velocity sign diagram, it is always positive. If I draw acceleration sign diagram, it is always negative. Am I right? Opposite sign, decreasing speed. Okay. So for the zebra, V2T is 20 minus 20 e to the power negative 0.1 t. So this is also always greater than 0. If you want, you can say ST, t greater than 0, whatever is it lah, the approaches. Okay. A2T is 0 minus 20 times negative 0.1 e to the power negative 0.1 t. So this is equal to 2 e to the power negative 0.1 t. So it is greater than 0 also. So therefore, so positive, both positive. So therefore, speed increasing. So you see, if you do from the graph, you also need to get the gradient. Am I right? Okay. So this one I would prefer to use the graph. The reason is because I can do part E and F. Am I right? So this will be a better choice for this question. Am I right? Okay, so we can do straight away part E and F already. Okay, before we do part E and F, let's go to part C. Okay, part C, what you need to do, you just take out your graphic calculator. You just key into your graphic calculator, wherever you key in your V1T dt. Okay, what is your answer? What is your answer? 38.9. Okay, 38.9 meter. Anyone in the class don't know how to get this? You go to math, FNINT. Okay? Okay, good. Now, how to interpret this? How to interpret this? Can someone interpret? The two with blonde hair? Either one of you? Blonde hair. Faster. How to interpret? Just now at the beginning, what did I say? You see? What did I say? So this is the key thing that you have to remember. Correct? So now you tell me how to interpret this. Okay, if you say total distance for lion, In the first? Yes. So you just need to say the total distance traveled by the lion in the first 3 seconds. That is a must to mention. That is a must to mention. That means, can or not? So that is an interpretation. Okay, so now, can I? So it's the total distance traveled by the lion in the first 3 seconds. Okay, if we go back to our this first diagram at t equal to 0. Okay, this is the situation, correct? So now at t equal to 3. At t equal to 3. Let me draw here. The lion initial position is here. Correct? So after 3 seconds, the lion is somewhere here. From here to here is 38.9 meters. So this is, the lion is here. At t equal to 3. You get me? On the straight line. Can or not? So that means from the initial position, the lion has traveled 38.9 meters after 3 seconds. Or I can say at 3 seconds, the lion is 38.9 meters from its initial position. If I want to state like that, also nothing wrong. Are you clear? So that is my interpretation. Have you written down, everyone? Okay, so this is the initial position. This is a position after 3 seconds. Okay? Okay, now let's go to part D. Okay, when you do part D, you just key into your graphic calculator, this one, correct? Yep. So what is your answer, Thaddeus? Okay, 30.71 meters. So how do you interpret this value? 30.71 meters. How do you interpret this? Do you get that? John, do you get that? You go to FNINT. Yeah, the function is, you should key in Y1 and Y2, correct? Just put Y1 minus Y2. You get that. Okay, who want to try? Okay, you said the distance between the lion and the zebra is 30.71. That means, okay, I interpret that one for you. You said the distance between the lion and the zebra after 3 seconds is 30.71. Okay, let me show it to you. That means when t equal to 0, this is the situation, correct? Here is the lion. Here is the zebra. Their distance is 40 meters. Okay, after 3 seconds, so that means the lion is here. Then the zebra is here. Their distance here is 30.71. Do you think it's possible? Then forever the lion won't be able to catch up with the zebra. Am I right? Still, they remember when we have this minus signs in maths, what word do we use? Whenever you have minus sign in maths, what word do you use? You can say take away, but this take away doesn't give you any sense about distance travel. Am I right? And in maths also, we know that for integration, correct? If I have plus and minus, I can split into two parts. Am I right? Can I do like that? Can. So if I do like that, can you interpret the first part? What is the first part in words? Total distance traveled by the lion. Okay, you just put in words first. After 3 seconds. Take away. This one is total distance traveled, because the area all is above, so I can put like that, by the zebra after 3 seconds. So correct or not? So in the first 3 seconds, the lion traveled 38.9. You take away. You count that one. What is the answer? $8.16. So this is not the situation, correct? So the actual situation. So how do you interpret this now? If I use minus, hurry up.
Distance traveled by the zebra.
Okay, yeah. By how much? Within what time limit? Within 3 seconds. Yeah. In the first 3 seconds, I can say the lion traveled 30.71 meters further than the zebra. Can I say like that? So that means now, how far is it away, the zebra from the lion? If I ask the question based on here. So now we look at the first situation. The lion is here at the beginning. So it traveled 38.9 meters. So it is here. Okay? The zebra is here. Here to here is 40. Correct? So it traveled this much. 8.16. So this is the final. This is the initial position. So this is the position of the zebra after 3 seconds. Am I right? So how far is the zebra away from the lion now? The lion is how many meters behind the zebra? Here. Yeah. So here is 1.1. Am I right? So it's 9.26 meter. So now the lion, after 3 seconds, the lion is 9.26 meter behind the zebra. You see or not? So I can make this conclusion. So therefore, so I can change this question. After 3 seconds, how far behind is the lion from the zebra? I can ask question like that. So I can say, after 3 seconds, the lion is 9.26 meter behind the zebra. So it's going to catch up already. Zebra faster run. Correct? You see or not? That's why I said you cannot say the distance between. It's not. Because they start from different position at the beginning. So the first sentence in the question is extremely important. Paham? So when come to all this, we have to be very, very careful. Yep. These two functions, the initial position is different. Okay, class? Can? So, this one, use the word difference. So the total distance traveled by the lion and the zebra, the difference is 30.71 meter. Or you put it in a better way. The lion traveled 30.71 meter further than the zebra. Dia lari lebih jauh. Okay? How much? Jauh? In the first 3 seconds, 30.71. So I can also ask you to calculate this, interpret this, then ask you question like this. So there is another extended question that I can ask. After 3 seconds, how far behind is the lion from the zebra? Hello? Yeah, please write down the question by yourself. Can or not? Are you okay? Okay, so I've answered part C, part D. Okay, let's go to part E. So how are we going to explain part E? So we go back to the graph and explain part E. So for part E, we are going to explain using the graph. This is for zebra. Yep. And this one is for the lion. All right. So you find this intersection point, please, so that to tackle for part F as well. Okay. So what is the answer? 5.60. Okay, now, who want to try? Who want to try? So now, you know that is a point of intersection. So that is your crucial point. So this crucial point, break the graph into two sections. Right, the left-hand side and the right-hand side. So how are you going to, based on the position of the velocity time graph, and explain? Please try. Hello, I want the ladies, please. Hello. Or anyone online? On your mic and start to explain. Cepatlah. You don't want to know whether your mind is thinking the right thing or not. Do you know there was once a lecturer asked one of the students, why every time you will put up your hand and answer the question? Do you know what the student answered? Because I want to rectify whether my answer is correct or not in my mind. Instead of waiting for the answer. You are at this age, you must be able to create some answer already. I even give you the hint already. So please try to express your thought. Hello, all the ladies in this class. Hey, don't put me down. Huh? Your teacher is also a lady. Huh? Men always claim that they are cleverer than ladies. Please disprove them. Hello, those online, on your mind and talk. Esther, Gladys, Nick, no. Nah, three of you are ladies also, please. Cuba. Faster. The zebra move faster. So you must, yeah, correct. The zebra move faster than the lion. So the distance covered by the zebra will be more than the distance traveled by the lion. So that means the zebra will be further and further away from the lion after 5.6 seconds. See or not? Yeah. After 5.6 seconds, the velocity or the speed of the zebra is greater than the speed of the lion. Is it exit? That means more than. So the zebra is going to move further and further away from the lion after 5.6 seconds. Therefore, they are closest at that point. All right? So that, do you get me? So you go by that. If you want to explain before that, also can. So F also done already. That is 5.60 seconds. Okay, now let's go to part G. So part, you should be able to do part G. That means for part G, what you do, you integrate from 0 to 5.6 Vt V1 T dt. Okay? Then you integrate 0 to 5.6 V2T dt. Okay. Then you look at the answer. So what do you get? This one is 64 point something, is it? Is it? 64 point what? 32. Okay, then V2T? 26, huh? 26.214. Okay, so what we need to do is, we know that at the beginning, they are how many meters away? How many meters away from each other at the beginning? 40 meter, correct? So what we need to do is, for this case, I will say, distance traveled by the zebra, okay, plus 40 meter, that is 66.21 meter, correct? This is greater than 64.32. So does the lion catch up with the zebra? The answer is no. How far behind the lion is from the zebra? I take 66.21, take away 64.32. Am I right? Yeah. So now the lion is 1.89 meter behind the zebra. So a lot of interpretation need to be done. So different scenario, you will have different interpretation. So we will see that. So we will see that in the application in part D. That is the application for other situations other than kinematic. So you have tons of homework to do, but you have tons of time to do also. So you have 1.5 weeks, 2.5 weeks to complete all your work. So there is no reason you cannot complete. So tomorrow I finish 5D, then everything will be done. Do you get me? So please. Okay, class. Thank you. Overshot 1 minute.
Thank you, Miss.
Yeah.